All right. So we are finally in chapter 2. Gentlemen, love the hand game, but you'll have to save it for later. We're in chapter 2 and it's all about quadratics. We're going to do so many things with quadratics. And the first thing is we've kind of got to understand some of the vocabulary. And so once I explain most of this to you, it's going to be ridiculously easy. It's going to make you happy. Today's going to be a friendly assignment. So use the graph to determine the behavior of the function between the indicated points. And we've got increasing, constant, and decreasing. Okay, so you guys are saying in between A and B it's constant, like it. B and C. How do you know it's increasing? Because we read from left to right, yes? Okay, so C and D. Oh, I can't see through the camera. And D? All right, so is that uber friendly?
Yes.
All right, uber friendly. Now this one is all about minimum and maximums. So what you need to know, if we have this shape, see how it's got a bottom? That's a minimum. It's the lowest point. If we have this shape, it has a top like a hill, so it has a maximum.
So we got 4 negatives.
So minimum versus maximum. Yes, ma'am?
I'm just taking a guess at this, but since it says all local minimum value of g, but you don't know what g is, would you just pick the lowest point?
So the whole function is g of x. Yes. So right here, let's answer Mia's question first, and then I'll go with you. So local minimum means anywhere along this function that is g of x, where does it have a low spot? So it doesn't have to be the absolute lowest. It says all local minimum. So we're looking for all of the valleys. And so notice this says g, local minimum values of g. So look for your values of x. Here's a low. What's that value? So we've got -3. I'm not going to type it in because I don't have a keyboard. And then where else? Here's another low spot. What's its value? 4. Okay, now all values of g at which there's a minimum. Now Alex is going to do something tricky to you guys. These mean, this one is the x values, this is the y values. And in the next question, chances are they're going to flip-flop those. So make sure you're paying attention to that, okay? So we found the x values, and now it wants to know what are the y values, where those minimums are. So here's my minimum. Now come over to the y. What's that value?
1.
All right. Now we find this minimum right here, and its value is? -2. That's how we do that problem. The tricky thing will be that they're going to probably flip it on even the next one. Let's look and see. Okay, A, am I looking for the x's or the y's? X's, this one I'm looking for the y's. And again, this one says a minimum, so I'm not going to do that one again.
So minimum is x.
Does this one say
Still minimum.
still minimum?
Still minimum.
I was hoping we'd have a maximum.
No.
Oh, we're going to talk about that one in a second. So let's make sure we understand this. All local minimum values of g. These are the x's. So I would be looking at -2 and 4.
-2, negative.
Oh,
And then this one, the y values that go with those. Jaden, Ricky? Thanks. So what is the y value that goes with this? -3 and -5. Okay, so we're already clear through problem number 7, just like that. Does anybody know the name of the shape? Parabola, right? Okay, so again, we're just learning some of the terminology today. And then tomorrow we'll start to learn how to graph these, and that's a big step in our Math 2 curriculum. So which way does it open?
Downward.
Downward for sure, right? Downward. And now it says, find the intercepts, both the x and y intercepts. Where does this cross the x-axis?
-2 and
Negative 2 and what?
and 6.
Is that a 6? I can't tell from here. All right, and our y-intercept. How many y-intercepts do we have?
1.
And where does it go through? Is that 2?
Yeah, that's 2. 2 or 3?
Is it 3?
Yeah.
1, 2, 3. All right. We all have bad eyes. I needed to zoom in on that, but then I wouldn't have it all where I could see it. Okay, so you are going to have 2 x-intercepts unless, what if your parabola sits, look at that, I can't even draw. Use your imagination. How many intercepts, x-intercepts would it have there?
0.
Well, let's pretend like that's touching the axis.
Oh.
How many intercepts would it have? 1. If it's just sitting on the x-axis, you would just choose 1. But see how this one goes through? That's why that one has 2. All right, let me clear that off, and let's see what else we're supposed to answer here. Find the coordinates of the vertex. So the vertex is the highest point or the lowest point. So what is that point? That's over 2.
2.
Up how many?
6.
Is it 6?
It's either 4 or 6.
4.
Is it 4?
4.
2, 4. Goodness gracious. All right. So vertex, the highest or lowest point. And then this last question is find the equation of the axis of symmetry. And that sounds really scary. And you're going to get it wrong for one reason, and I'll show you what that is in just a second. It says find the equation. Let's erase this. So find the equation. Equations have equal signs. So if you don't have an equation, you're going to get it wrong. The axis of symmetry is where this parabola could fold right in half. Pretend like that's a straight line. Could I fold the parabola on itself right there?
Yes.
What number does that go through? 1, 2. So I know I have to have an equal sign, and it's 2. And is that the x-axis? Yes. Your equation is x equals 2. We're going to go to the next one, and we'll just do 2 things. We'll do the vertex and the axis of symmetry. And then you should be able to get through your homework pretty quick. Yeah, I know. All right, what's my vertex on that one?
Upward.
What is it?
Upward.
What's my vertex on that one?
2, negative 6.
So that's
2, negative 6.
2, negative 8, I think.
8? Yeah, 8.
All right. So I know you guys are good at the upward and downward. I tricked you by skipping that, didn't I?
Yeah.
And Mr. Katakata, want to have your head up during the lesson, please? Thank you. All right. So imagine this axis of symmetry, right? Where does it go through on the x-axis?
2.
All right. So I wrote 2, and Alex told me I have it wrong. Why?
Equals x.
X equals 2. Absolutely.
What if Marcus wrong if we put 2 equals x?
I don't think so. I think 2 equals x would be acceptable. Good question. All right, jump in and get that done.